Hi, we're back. So we are doing it right. I didn't have my equation in that y equals. I forgot to put that in there. So it actually graphed the last equation that we graphed. So that's why we got a different graph. So I'm just going to keep recording and we're going to keep it real. If we did second quit, remember we got 5,900 here. So I'm going to put 5,900 here. So then I put into my y equals equation, negative x squared minus 140x plus 1,000. I'm going to keep my windows where they are at negative 100, 100, 10, 0, 20,000 by 1,000. And when I graph, I have that minimum now. Now it's a maximum because it was a negative, so it's concaving down. So if I go to second trace and I want to find my maximum, I'm going to go over here, my left bound. It says x is 0, but I don't want it to start here. I want it to start way over here. So I'm going to go over. I know it's got to be at least negative 70, so I'm going to keep going. See, my cursor's coming now. So I know that I want to get to this side of the curve. So I'm going to go from here and then to the right side of the curve. And then enter, enter. And there it is, negative 70 and 5,900. So we were right the whole time. It's just maybe a little nervous. All right, so I want you to go ahead and find the vertex and write an equation for the axis of symmetry for this. Remember that the vertex is the opposite of b over 2a. So it's going to be the opposite of 6 over 2 times 1. It's going to be negative 6 over 2. It's going to be negative 3 for your x value. Then you're going to put negative 3 in for x squared. For x, plus 6 times negative 3 plus 2. And calculator doesn't do errors, so I'm going to put it in my calculator. Parentheses negative 3 squared plus 6 times negative 3 plus 2, and it gives me negative 7. So my vertex is negative 3, negative 7, and then my axis of symmetry would be x equals negative 3. So let's check it out on the calculator. Y equals, and we're going to put in x squared plus 6x plus 2. And then I'm going to do my window as negative 10 to 10. Negative 10 to 10. Just to check. It should be crossing at negative 3, negative 7. Check it out. And I'm going to say, well, let's calculate my minimum. And my left bound's going to be like that little thing on the left side to the right side. And then what is it? And it says negative 3, negative 7. Beans. Right. Find the vertex, axis of symmetry, and the x-intercepts from this graph. X-intercept is going to be when y is 0, or you could do the quadratic formula, or you could do factoring. I'm going to pause it. This is what I would do. I'm going to try and factor first. So I'm going to find my x-intercepts. And when x-intercepts means that y is 0. And I'm doing that first because it's going to be the hardest thing for me to do. So if I put y is 0, 0 equals 5x squared minus 20x plus 15. So I'm going to divide everything. I'm going to factor out a 5 from everything. So I'm going to divide this by 5, divide this by 5, divide this by 5. And I get 0 equals x squared minus 4x plus 3. So when I do my factoring, I can say 0 equals x minus 3 and x minus 1. So my zeros are going to be at x equals 3 and x equals 1. So my x-intercepts are going to be 3, 0 and 1, 0. I'm going to copy this, paste it down here. To find my vertex, I'm going to say my vertex for my x is going to be the opposite of b over 2a. So the opposite of b would be 20 over 2a would be 2 times 5. So it would be 20 over 10, which is just 2. When I plug 2 in for my y value, I have 5 times 2 squared minus 20 times 2 plus 15. That's going to give me my y value, my vertex. So I'm going to go quick. I'm going to go 5 times 2 squared minus 20 times 2 plus 15. My y value is negative 5. So my vertex is 2, negative 5. Now did I answer all the questions? Axis of symmetry. Axis of symmetry is where the vertex has the value for x. So the axis of symmetry is when x equals 2. Now I'm going to check all my work, and I'm going to put that into my calculator. Y equals, figure it out, and I'm going to do 5x squared minus 20x plus 15, and then I'm going to go to my window, and my vertex is 2, negative 5, so I'm going to do the negative 10 to 10 thing again. That's cool, and I'm going to graph. My graph says, there's my axis. And there's my, if I look, I have my x-intercepts at 3, 0 and at 1, 0. So, graph looks good to me. Good job. Okay, so let's see how all this applies with word problems and whatnot. It says the daily profit for a product is given by this function, where x is the number of units produced and sold. Graph this function for x between 0 and 4,000. Describe what happens to the profit for this product when the number of units produced between 1 and 2,000. What happens when the profit after 2,000 are produced? So if this is between 1 and 2,000, it means what happens to the profits here? It means the profits are increasing, and then the profits are decreasing. If a function is decreasing, then the x values on the function's graph increase from left to right. The corresponding y values decrease. If a function is increasing, then the x values on the graph increase from left to right, the corresponding. So if it goes from 0 to 400, you're increasing in profits, and then from 400 or 2,000, from 2,000 to 4,000, they decrease in profit. So what does it mean when this graph starts decreasing? It means that there are less and less profits being made. So maybe it's going out of business, or out of date items. So if a ball is thrown up at 58.8 meters per second from the top of a building that is 25 meters high, the height of the ball can be modeled by this, where t is the number of seconds the ball is thrown. So you notice that down here it doesn't start at 0, 0 because it's not starting from the ground. It's starting from that 28 because it starts at 58.8. It starts at 25 meters on your y-axis. So find the height after 6 seconds. So let's put that into our calculator. Y equals, and if it's 25, let's clear this out. 25 plus 58.8x minus 4.9t squared minus 4.9x squared. And so I'm not going to graph, well, here, let's graph it. Here's our windows, 0 to 18. Your windows are on your x is 0 to 18. We'll go up by ones. And then on y is 0 to 400. And we'll go up by hundreds. It doesn't matter. So if I graph it, there's my graph. And it says find the height after 6 seconds. Well, that would mean when t is 6. So I'm going to second table set, and I'm going to go up by ones. And then I go to my table. Second graph would be table. And you can see that after 6 seconds, it's 201.4 feet in the air. Find the vertex. So let's go back to second graph, second calculate. And we want to calculate it's going to be a maximum since it concaves down. And it's over here, but we need it to be over here because it says left bound. So let's go to the left side of that. And let's go to the right side of that. And then I wanted to guess. And it guessed to it was at 6 and 201.4. Oh, look at that. 6 and 201.4. What happens to the ball after 6 seconds? It stops in the air and it starts decreasing. Starts coming down. Is right here. Okay, where x is the width of the pen. A is x times 300 minus x, where x is the width of the pen, is quadratic function, is it? The answer is yes, because x 300 minus x equals, if I distribute the x in, minus x squared, and a quadratic function has an x squared. So is it a quadratic function is yes. And what is the maximum area of the pen? Maximum area would be A equals 3 times 300 minus x. I made a mistake. Put the x another 3. So let's find out what that would be. We know that it's a minus x squared, so that we know that it opens concave down. So the maximum will be up here at the vertex. So if we graph it, we can find the vertex. And there A is x. Here. X times 300 minus x. What should we have our windows be? Let's go. So in order to find that vertex, we're actually going to use the vertex formula, and we're going to say we're going to use this. We moved it around. We moved the equation around, so we're going to use this one. And what we're going to say is the A equals negative x squared plus 300x plus 0. The reason why we're going to do that is because now we have a value for our A, our B, and our C. Our A is 1, our B is 300, and our C is 0. So the vertex is the opposite of B over 2A. So the opposite of B would be negative 300 over 2A, which is 2 times 1. So it would be negative 1500. Oh, this A was a negative 1, so it's actually a positive 1500. Don't forget this negative. So when that is, let's find our y for our vertex. And so y would equal negative 1500 squared plus 300. It's not 1500, it's 150. Getting crazy. Use a calculator. 300 times 150 plus 0. So if we go in our calculator, we have here negative parentheses 150 squared plus 300 times 150. Then it would be 22,500. 22,500. So this would be at the point 150 on x and the point 22,500 on y. So our max area would be our x value. So it would be 150. And what are we talking about so we can label it correctly? It doesn't say. The maximum area within is 150. So interpolation, you see it, is going to be the evaluation of a model for the value inside the interval. And the extrapolation is the evaluation of a model for a predicted value outside the interval. So inter versus extra. Let's see if we can put this in a different way. So we can draw a picture of what that might look like for you. Okay. Inter versus extra. So if we have a curve, and we have a curve, interpolation is the one inside the interval, so this space here. Extra is if we're talking about this space here. So let's look at quadratic regression. Find the quadratic function that is the best fit for this below. So we're going to do this like we did our linear regression, except it's going to be a linear or quadratic regression. So use a quadratic regression feature in your calculator, and then we're going to put it in the form ax squared plus bx plus c. So as you see here, we have a list 1 and a list 2. So we're going to go to our stat button and then edit. List 1, I'm going to delete these. I'm going to delete these, whatever they were before. definitely are different now. So here my X values are 0, 2, 4, 6, 8, and 10. And my Y values are 0, 405, 1607, 3610, 6389, and 9981. They enter the same, so I'm going to second quit. And then I'm going to go to stat again, and this time I want it to calculate, but now I want it to calculate a quadratic regression. So it's a quad reg, and then I'm going to do the second stat to get my list 1, comma, second stat to get my list 2. And then I wanted to put it in my Y1, so I'm going to go to my bars. There it is. After I put my comma, I want to go to my bars, and then go to Y bars, and the function. And there it is. Now, if I put my Y equals, remember I said to put it in 1, so there's my Y equals equation. So I'm going to write it here, Y equals 0.04, oh, I see a 4. Wait a minute, I got the wrong one. Second quit. Second quit. Oh, I put quart reg instead of quad reg. So I'm going to do that again. So I'm going to go to stat, and I want it to calculate a quad reg, number 5. And then that. And then my Y. So there it is. And I'm going to pull it closer so I can read it. And I'll write it up here. Y equals 99.3, we'll say. X squared. Plus 5, we'll say, X. And then plus or minus 0.68. Now, if I want to plot it on here, I'm going to go to Y equals, and I'm going to come up here to plot. And I'm going to turn it on, because I want it to list the points as well. And I'm going to go to, what does that look like? What's my window look like? Crazy? Yeah, I'm going to go negative 10 to 10. Well, there's the linear regression that puts us there. It's coming. Ooh, let me go on my Y, my window, and I'm going to go on my X. I'm going to do negative 2 to 2 because I want it to be thinner. There we go. All right, let's look at the next one. The table shows a projection in billions of dollars for hepatitis C treatments for a certain region from 2012 to 2016. So we're going to do what's the quadratic function that best models these areas as a function of the number of years after 2010. So the number of years after 2010, so X is the number of years 2010. So 2010 is 1. So by this time, the year would be 2, 3, 4, 5, and 6. So I'm going to put that in my L1, stat, edit, list 1. And list 1 is going to be 2, 3, 4, 5, 6. And list 2 is going to be 3, 3.1, 3.9, 5.1, and 6.6. So I'm going to go to my second quit, and come up with an equation. So I'm going to go to stat, calculate number 5, which is a quadratic regression, and then I'm going to do list 1, comma list 2, comma I want it to go into my y 1, and there it is. So if I go to y1, oops, I go to y1, there it is. It's going to be 0.22 to, I want to say 0.23x squared minus 0. Minus 0.91 x plus 3.86. And then graph the model. So graph, I'm going to go to zoom 6, which will give me the negative 10 to 10. There's the, because I turned my plot on, it graphed the plots and then the lin reg. So you see, those are the points in the lin reg. What are the sales projected in 2017? Well, in 2017 is when it would be 7. So I'm going to go to second table, and I'm going to go down to where it says 7. And where it says 7, it says 8.7. So it's going to be $8.7 billion. So an x equals 7, y equals 8.7. If you don't have it to where it's doing that for you already, if you go to second window, and then have your table start at 1, and it can do auto because then you just go over there and it'll start at 1 and go up the ones. All right. Good luck. You got this.